From the very start of our work with MVC and Entity Framework, we focused on code first development, right? We defined our model classes and we had the database generated automatically using migrations, right? So in the real world, that's often not how things work. There's an existing database that we've been hired to build a web app to interface with, right? So if that's the situation, it is possible to still use some of the tools in any framework to give us a head start so we aren't manually creating all of our classes to match an existing database, right? It is sometimes referred to reverse engineering the database, okay? So we can generate model classes from an existing database. Now, I'll be honest, this was actually perfected to a fair degree in the earlier version of Entity Framework before .NET Core. You could actually incrementally have it apply changes as changes were made in the database. Not quite that smooth, and although the truth is, even then there were issues that came up from time to time. But we do have a tool that does the basic job for us, right? We can use it either command line or in the package manager console. And since we've done most of our work in the console, I'm going to stick with that example for our code here, right? So it's just a package manager command, basically scaffold dash db context, right? And basically you pass the connection string and the provider name, because of course we might be using SQL or we might be using SQLite, et cetera, right? And of course, there's a bunch of other options, okay, that you can use as well. So just to mention here, here's some examples I have. So using SQLite, it might look like this, right? Scaffold DB context. That's my connection string. That's all it is in my current medical office example, right? And then we specify the provider. Well, the provider is EntityFrameworkCore.SQLite, right? And then I'm getting into here specifying the output directory. Pretty much always are going to specify an output directory, whether it's going to be a models folder or something. Just be aware that all of the scaffolded code, not just the actual models in our normal way of thinking about it, but even the DB context and so on, will all be created inside this output directory. Now, just for comparison, here's a line that would work, for example, with a SQL Server. Right here, the connection string is the main difference we see right up front. So dot backslash, that just means it's on the local machine, okay? It's a named instance of SQL Server running. The name is SQL Express. The database is one here called Ironwood, and we're just trusting the built-in connection here, the Windows authentication that we have, right? So the provider is EntityFrameworkCore.SQL Server, and I might have an output directory, who knows, models or whatever, right? So very, very similar. It doesn't do a huge difference going from one provider to another. We just say what provider it is and give the appropriate connection string, right? Now, there's other options, right? Output directory is one that you pretty much always use. You can say dash data annotations, and that way it adds annotations into the classes. Otherwise, everything is done in the Fluent API, because remember, if you're doing the whole database, it will also create a DB context for you with all the DB sets for the tables and so on, right? And all the work is done in the Fluent API. So you can do that option, but you know what? I have to be honest, I don't find it that useful because the way it writes the annotations, more than half of them that it creates, you probably want to change anyway, right? And of course, annotations is something else. If you do a dash force and you overwrite existing files, so you make a change in the database, you want to overwrite your model design in your project, then any annotations you've changed or added in the actual classes, they get overwritten, right? So that's another topic we'll talk about later on. The option use database names. Basically, it tries to match based on the names of the fields and tables in the database. It tries to uh, make some changes to them where required to better match the .NET naming conventions, right? If you wanted to just stick with whatever names are there in the database for fields and tables, then you can use database names. Schema, that just means we're only going to scaffold objects in a given schema. But of course, that's not applicable to all databases, right? We don't have schemas in SQLite. Something else that can come up. Now, usually this is something afterwards, right? Normally, the approach would be you just scaffold everything from the database because you're starting a new project based on an existing database, right? But you can just do individual tables. And that might come in handy if you've just made a modification in the database on a given table. Then you could just rescaffold that one table with a dash force as well and overwrite the class related to that one table in your models, right? So it gives you a fair bit of flexibility. Um, I'll just mention here again, many developers will scaffold all the classes right at the beginning, right? And then do any work that's necessary to manually keep design changes in sync. So if you manually make a change in the database, go to your classes and manually make it there, rather than using this tool over and over again, even to regenerate classes for individual tables. It avoids some issues, especially if you've done some work. Um, in annotations and so on in your classes, you don't lose them. By the way, you can also just do some research on your own on a metadata class. That's a way to create a class that sits in parallel with the actual model class that just contains all the metadata, all the data annotations. So you can put them there and it stays there even if you overwrite the main class itself. And that way, all your annotations, the custom work you did writing them, will be persisted. Anyway, that's another topic. All right. So yeah, so manually doing it is often done. By the way, this is a link itself. Okay, so when you click on the title here, it goes to this whole section on reverse engineering and gives some examples and so on and some explanations. Here's a good thing to be aware of is all the limitations, right? For one thing, all it knows about it, this case, is the database. So for example, think of our Audible and our iAudible interface. Well, it doesn't know anything about that. It just knows that a table has got all these funny looking fields created by, created on, updated by, updated on, and so on, right? So it's naturally just going to create all those in a given model class. It doesn't know anything about hierarchies and so on and so forth, okay? So there's some limitations and things to be aware of. But, it does do an awful lot of work for you in a pretty simple way. So let's just quickly do a demo. What I have is I have the 10 point whatever from lesson 10 version of our database open. So all I did is I opened it, I uncommented it, because remember I had all these commented out, these lines in programs, so it would actually recreate the database, and I ran it once just because my posted solution, of course, I've deleted the databases to make it smaller to download, right? So now I've recreated the database. Can't demo this going from database first without the database being there. So I ran it once just for that. Okay. So let me just go into the Package Manager console, and I'm just going to grab that command right out of Blackboard here, the one for SQLite, right? Because I based it on this example. Notice that the file name matches. By the way, I chose this version. I went back not to the 11, but to 10, so that the security tables were separate, right? Just to keep it cleaner and simpler. Okay, so I'll just paste that in here. Scaffold DB context, that's my connection string as shown here in app settings, right? For the medical office context. And there is the .SQLite for the provider. And I don't want to mess up with my models, so I'm gonna define an output directory of new models. We'll build, succeeded, and boom, there we go. See our new models folder. And if you start looking through, I'm just gonna clean up the screen here a bit. So every file that was scaffolded will be in this folder here, right? So, bring up anyone, there's appointment. Now, things are going to look a little different, right? Notice that, we just have data types here. We don't have any annotations whatsoever. You'll notice the use of the word virtual. A student asked about that the other day as well. And basically, it's in the earlier days before .NET Core, .NET Framework, you would add the virtual keyword to properties that were navigation properties usually, so that Entity Framework could override them, right? So you can override properties by making them virtual. And that was mainly used for lazy loading. Now, when it came to .NET Core, for the first long time, there was no such thing. There was no support for lazy loading. Remember the difference. Eager loading means you get all the data right in your first trip to the database. Lazy loading is you only go back for things if you really turn out to need them afterwards, right? To support lazy loading, you had to make your properties virtual. Now they have started to add support for lazy loading back into .NET Core, although it's not exactly perfect as as it was before. But odds are we aren't really going to be using it. But you know what? There's no harm. The fact that the virtual is there, it makes no real difference. There's no disadvantage to it. So you can remove them all if you really don't want them, but there's no need to, right? Let's bring up something a little more complex, like patient, right? So here's all our properties. Here's all the navigation properties, okay? And notice how the necessary ones are being instantiated here to empty hash sets and so on. So this is all written for us, all this code, right? Ah, there you see that? There's all my audit ones. Well, of course they're there, right? Because it knows that they were in the table. So it doesn't know anything about the auditable class, which is why we don't see one as scaffolded. All right, let's just have a quick look here at the actual medical office context, right? So here's the newly written context prepared for us, right? So there's all the DB sets, okay, that it sees as tables. So it's prepared ones for each one. And there's some options here, a warning about the connection string and so on. You know, you might want to think about not having it here, but anyway, this is just because there's only so much it can do since it doesn't have access to your whole project. But here in the on model creating, you'll see lots and lots of code here with Fluent API, you know, creating indexes and so on. Things we've never even bothered seeing because it just happens automatically. Like foreign keys, there's always an index created on them and so on and so forth, right? So feel free to have a look at it, see all the code that's here. So it is a workable way to get all the models and the context in place. You'll often find you have a bit of work to do to clean things up, especially if you do want to start providing meaningful metadata, right? So for required properties, for example, okay, to actually supply a proper error message if it's not given and so on and so forth. So that's where you'll either get into adding annotations and accepting the fact that, well, if I put them right in the class, I have to manually update the classes from now on every time there's a change made in the database. Sometimes in the real world, that's not a huge amount of work, believe it or not, because often the databases are well established and you know, only have minor changes need to be done to them once in a while. So it's entirely up to you if you want to get into metadata classes or not. But anyway, there's a quick demo and you can play around with it, see what you think. All right. I just have a link to another resource that's kind of nice out here. Shows you a bit about it. And also he mentions in here to get more help. I think it's in here. I'm not seeing it. He just shows, you know, you can just get help on the actual scaffold DB command, right? I'm pretty sure it's in here. I just can't see it right now. Oh, there it is right in front of me. Okay. So there you are. Just, you know, run that inside your package manager console and I'll do that when we come back. Oh, I closed Visual Studio. Ah, never mind. Uh, yeah. We know you want to open up nice and slow. Okay. This is as long as the rest of the demo. There we go. So here's a detailed explanation showing you all the different options and the syntaxes and so on. So, you know, there's lots of help available to do this if it ever comes up for you. Again, generally, if you have the luxury of doing code first, you're going to feel as a developer so much more in control of things. But hey, if you're given an existing database, boy, this saves a ton of work rather than manually trying to generate all the classes, all those classes yourself. Okay.